Good morning. We've been talking about thermal energy. This is a Prezi that I've put together so that you are able to review for your test tomorrow. Make sure to do your whisk right after you're finished viewing it, or feel free to view it several times so that you're able to summarize the presentation better. Starting off with thermal energy. If you recall from our class discussion and from a previous class a couple of months ago, we talked about different forms of energy. There are 7 forms of energy that we've discussed in class. One of them was sound. The other one was chemical energy. Mechanical energy is the energy that you use your hands, your body, your feet to produce some type of movement. For example, strumming a guitar, your fingers are the ones plucking the guitar, and that is generating some type of motion. The other thing, your feet are pedaling the bike, and that is generating your motion from point A to point B. Electrical energy that you're very familiar with, heat energy, solar energy, and light. And among all those 7, we find heat, which has been the topic for this week. Okay, heat is not to be confused with temperature. A lot of us confuse heat with temperature, and we think that they are one and the same. And temperature actually refers to how hot or how cold a body is. Inversely, heat is a form of energy, okay, that when it comes in contact with matter, molecules, it makes them move. It makes them move faster. It makes them vibrate. Okay, so notice the difference between heat and temperature. If you recall, one of the little demos that I did for you was boiling some water, and then right next to that cup of hot water, I poured cold water into a separate glass, and I used food coloring to drop a yellow and a blue drop in each cup. And you and I observed the different results. If you recall, the hot water, you were able to see that the yellow and the blue mixed very quickly to make green. In cold water, the yellow and the blue, it took about 20 minutes for it to mix into a greenish hue. But if you recall, as we moved on to another part of the lesson, we could still see the little dots that had not separated, that had not mixed completely in the cold environment, which leads us to believe, what I wanted you to get out of that was that molecules behave differently in different environments, okay? Molecules in cold water move very slowly because they have very little heat. You must understand that when molecules are moving, whether they're moving fast or whether they're moving slow, they have just a tiny bit of heat inside, okay? And we'll explain this later in the Prezi. But the molecules, for the most part, in cold water, they moved very, very slowly, while molecules in the hot environment, in the heated environment, were moving very, very fast. And proof of that was that because the molecules were moving very, very fast, they were able to mix right away. Okay, and you're able to, some of you got to see the little animation. Okay, when you have a chance, go ahead and click on the animation. Right here, here's the address. Make sure that your computer has shockwave player. If not, it won't play correctly. But you're able to slide the cursor to a hot environment, and you're able to see how the molecules move faster. And you're able to, in this animation, slide it to a colder environment, and you're able to see how the molecules slow down significantly. Okay. The other thing that we talked about was that heat moves. And it moves in such a way that you're able to see how it moves in 3 different ways, okay? When we talk about thermal energy, we're talking about radiation, conduction, convection, collectively, okay? And when we say thermal energy, we're talking about how heat moves, okay? How heat gets transferred from this place to that place. We discussed the 3 different ways that this happens. And the first way that we talked about was radiation, okay? Radiation happens when heat energy is transferred directly from the source to something else via waves. Notice that in this picture, the waves are coming from the sun into the earth or into the world. And how do we know? Because we see the arrows coming from the sun onto the world. The world is not touching the sun. The sun is not touching the world. Okay. So when you feel the heat waves coming directly from a heat source, and you're not touching the heat source, but you feel the heat, that means that that heat is coming at you via waves. And whenever heat is transferred to you via waves, we call that radiation. Okay. Convection is another one that we talked about. Remember, this is the experiment that we did with the rice. Okay, it's difficult to show you the current that was moving inside that boiling beaker, or that boiling water in that beaker. But once I put the rice, you were able to see how the rice was moving in a circular motion. And this happens, convection happens when particles or molecules with a lot of heat move in a liquid. Okay, there's molecules of water, obviously, in water. Okay, when they are heated up, they're gonna move. Okay, they're gonna move in a certain direction. This happens within a liquid, and this happens within a gas. Okay, it doesn't happen within a solid. So liquid and gas, once you get those molecules heated, they will move in a certain direction. Okay, air or water is heated at the bottom, as you can see in this picture, and the heated molecules, they travel to the top. Okay, they cool down just a little bit. And remember that cool down molecules, or cold molecules, or cold particles, they get a little heavier, and that's why they sink down. Okay, so the order that this happens in is that, because of the heat source, the fire is the heat source. Okay, comes in contact with the molecules of water at the bottom of the pan. And they go ahead and travel up because they get lighter, they get less dense. Once they reach the top, those same molecules get a little heavier, and that's why they sink to the bottom again. And when they sink to the bottom again, they get heated up again, and the process starts all over again. And this makes that circular motion happen. Okay, that is, whenever you see a current, whenever you are able to observe a current, okay, of water, let's say in fluid, in this case it was water, you're able to observe that, and it's moving in a circular motion. We're talking about convection currents. Okay, we're not talking about heat getting transferred in waves anymore. We're talking about it getting transferred in a circular motion within a liquid or a gas. Don't forget about gas. The next one that we talked about, or the last one that we talked about, was conduction. And conduction is a form. Heat is a form of energy. Once again, that when it comes in contact with matter, which anything that it touches physically, it makes those atoms and molecules move. Once atoms or molecules are moving, they collide. This is the bumping we talked about yesterday. Okay, they collide with one another. So you have a molecule that is moving, and it bumps with another molecule. It makes that molecule move. Okay, so remember, we talked about the molecule. Once this molecule starts moving and it touches another molecule, the other molecule starts moving as well. Once you see that bumping, that colliding is going on, that is the reason why when you hold a metal rod over fire, the heat travels from here in this direction, because you're exposing the molecules of this wire here to heat. The candle is the heat source, and those molecules are going to get hot, and they're going to start moving. Well, they're going to start bumping the molecules right next to them, and the molecules right next to them, and pretty soon, if you don't let this go, you're going to notice that the heat got transferred via conduction. There was a collision of molecules. This hot molecule turned this molecule hot, or it made it vibrate. Okay, and it moves in this direction. When that bumping happens, when that collision happens, it's not radiation, it's not convection, it's conduction. Okay, this bumping into other molecules makes those molecules move. In this way, heat gets transferred. For example, right here, the heat is getting transferred from this end to that end. Ultimately, it's going to get transferred to your hand if you don't let it go. Okay? Remember that energy, because it's constantly moving and it's constantly getting transferred, you should know that there's a law of the conservation of energy, says that energy is neither created nor destroyed. It is just transferred. Okay? And energy, because it's moving, in this particular case, heat energy is moving, it gets transferred kinetically. I want you to remember, go back to your notes. Potential energy is energy in waiting, and kinetic energy is energy that's already moving, okay? There is there should be a link here. I'll go ahead and check it out right now, but there is a video that I want you to see, okay, that on Bill Nye, and he explains to you on heat energy. It's a 2-minute video. He explains to you how because the molecules, even in cold substances, picture an ice sculpture. I know that everybody has seen really pretty ice sculptures, swans, flowers, you know, that they take to parties or weddings. These ice sculptures, the molecules inside, they're moving a little bit, okay? And what I want you to understand is that molecules that are moving a little bit have a little bit of heat in them, okay? So I don't want you to think that just because water molecules are in a cold environment, there's no heat. There's very little heat in there, because remember that heat makes molecules move, okay? I'm hoping that I can fix this and I'm able to include that video for you, okay? So this is the presentation on thermal energy. Remember to do your whisk, and remember to bring any additional questions before the test tomorrow. Thank you for listening.